It's December and the rain has come, and I'm getting ready to take the reader and battery out to Oak Creek. I've been working on a new power supply system, whereas previously we used these sort of batteries, these deep marine, 6-volt marine deep cycle batteries, T105s from Trojan. Moving to a new system using old Tesla battery modules, which I'll show you in a sec. But first I want to show you what I've done to the reader in order to accommodate the different battery. Here, of course, is the reader guts, radio board with the controller underneath, the logger, the multiplexer. And up on the lid here, I have put an external power supply. So what does this do? This lighting. Okay, so battery voltage comes in here to these terminals inside here and through these wires to here. This board here is a battery protector switch from CZH Labs, aka Electronics Salon or something like that, on Amazon. And what that does is there's some switches right here on this red module, red little bit here, with which you set the voltage at which you want this to shut down power out. So power comes in here, DC power in, DC power out over here. And what I've got it set to now is that it will cut power when the battery voltage reaches 20 volts. And then here, the little blue board there is a buck converter. That is, it's a voltage regulator switching mode power supply, SMPS, DC in over here and DC out over here, and the voltage is adjusted with this potentiometer little blue thing with the little screw on top there. Right now I've got it set to output 18 volts approximately. And then finally got power into this thing that is from Oregon RFID. Oh, by the way, this is, I believe, the SNPS here, the blue board. That's from Drock, I think, also via Amazon. And then over here from Oregon RFID, I have a power filter, which is essentially a what you can call it. It's a choke, common mode choke, I believe. And it's essentially a noise filter. So voltage in, voltage out over here, and then, of course, voltage then being supplied down here to the reader through the logger power input. So here's the new battery that I'm going to be using. This is one of them anyway. I'll show you the other one as well. It's a module from this is a battery module from a Tesla Model S. So it's packed with the little 18650, I believe they're called, the little, you can kind of see here the individual cells, slightly larger than AA size cells. And the battery terminals are over here under these. I've labeled them positive and negative. There's the negative terminal and the positive terminal. I've got here my wrench to loosen or tighten those terminals. And like so. You can get these on eBay for roughly $1,000, maybe a bit more depending on the mileage of the car that they were taken out of. Since Tesla has such a good warranty on their batteries, there is essentially no automotive secondary market for batteries taken out of wrecked Teslas. So what the auto parts people do is when they get a hold of a wrecked Tesla, they take out the battery and they sell these modules on eBay for people to use in their solar and their battery backups for, say, solar systems for supplying RV power, that kind of thing. Essentially the DIY market. And these modules have voltage output ranging from about 25 volts down to about 20 volts. The actual highest voltage, I believe these go up to 25.2, and they can go down to 18 point something. However, in order to best preserve battery life, you don't want to take them all the way up or all the way down. I got this charger from a little company called Solar Genie, specifically made for these Tesla battery modules. And just use electrical tape to put the little 2-page manual on top here. So AC power comes in here, and DC power comes out, and I've connected a couple of wires to this, what do you call it, Anderson connector, I believe, so that I can hook it up to these terminals with the socket. So this will charge up to 25.1 volts, I believe. Specifically designed for the Tesla modules in order that they not be overcharged, or that is not taken all the way up to 100%, which apparently shortens battery life. So as I said before, I've got here a battery protector switch, this board here, that will shut down when the voltage reaches 20 volts. And 20 volts is about at the top. If you imagine the voltage versus power output curve going something like this and then diving off the deep end, 20 volts is near that elbow where any lower and you're really taxing the battery. This will shut down the system when the battery reaches that voltage. Now there is a feature in the reader to turn off the reader when the power supply voltage reaches a certain level that you can set. However, that's not going to do me any good in this case, because I've got this power supply here set to 18 volts. So that will output 18 volts over the full range of input voltages, say 25 down to 20 volts, provided by the battery. So that therefore doesn't provide any mechanism. I could set the reader to shut down, when voltage drops below 18 volts or something like that, but by then the battery would be like 100% depleted, and that would be bad for the battery. Switching mode power supply I chose at least in part, because it has a switching frequency that's higher than the radio frequency at which the radio board operates. That is, the radio board broadcasts and receives in the 134.2 kilohertz and below range. This switching mode power supply switches at 180 kilohertz. That's a bit low. It's lower than recommended, but it appears to be fine. I've done some tests to see whether this whole get-up system here works, and it does seem to work well, especially with the noise filter here. In order to further reduce any transmission of noise from the switching the airwaves, that is, you can get two different kinds of electromagnetic interference. You can get that conducted over the power lines, but you can also get electromagnetic interference broadcast as radio waves. So I've got this external power supply mounted, it's taped down, and then I've how did I get this down here? Oh, well, I guess I just taped down this thing, this piece of metal from an old computer. I can't remember. This was like a hard disk case or something like that. And then I've just got this, that's the lid for that particular case to go on top, complete with all sorts of labels. As you can see, just diagramming for the user what's going on here. That should at least limit any noise from broadcast with the magnetic interference. And in this case is grounded to the grounded through this green wire to the steel case that the reader comes in. One of the nice things about having this adjustable power supply is that it gives me another knob to turn in terms of power consumption. So, in general, you will get a better read range with the reader when you operate at higher voltage. Of course, higher voltage is also higher voltage at the same current is more power. This reader is essentially limited to about 24 watts. You don't want to operate at using power more than about 24 watts. Now, for a given battery voltage, if you find that your antenna is drawing too much current, then if you're going to just be stuck with that battery voltage, then your only option for reducing power consumption is to change the duty cycle of the reader. That is, the reader broadcasts for, say, 50 milliseconds and then pauses and listens for 50 milliseconds. So 50 milliseconds broadcasting, 50 milliseconds reading, that's a 50% duty cycle. I can reduce the power consumption by reducing that duty cycle by increasing, say, the pause time. However, increasing the pause time reduces the frequency of reading tags and reduces the sort of maximum velocity that tags can have as they zip by the antenna, and we still expect them to be read by the reader. So this is nice because it gives me another knob to turn. If the whole thing is drawing too much power, then I can simply turn down the voltage here in order to get that power consumption within spec. Alternatively, I can turn it up a little bit if my power consumption is still below spec and I want to increase my read range. I could turn this up. I could turn it up as high as say 20 volts. Although when the battery has 20 volts, I won't get quite 20 volts out of this, especially when it has a load on it. The voltage here would drop below 20 volts because there's always going to be a voltage drop across a DC-DC buck converter. Welcome to my basement, the rest of the basement. So this is the backpack with the other battery on it. We got this backpack to carry the lead acid batteries. I haven't been using it because it's just a bit awkward and really hard to carry more than one, and geez, for the short distances I've been carrying them, might as well just carry them with the handles. However, these Tesla modules are a bit awkward and there's no handles, so pulled this backpack out of storage, and you can see I've got it strapped on there, and there's that ledge at the bottom there that's folded out, and it's got the hip belt and everything. Nice big, pretty heavy duty external frame backpack. I just wanted to show you the battery. I wanted to show these little copper wire terminals that I've put on here in order to connect the power to the reader, because the reader power wires have these little clips, so I can just clip onto those. Here's the terminals up close. So again, you can see the copper terminal that I've just got bolted on with the terminal bolt there, and another one over here. I've tinned the copper with solder. Back at the reader, these are the type of connectors that I've got on the reader right now. So yeah, these will work real well with with those little copper wire terminals that I put on the battery. So I'm almost ready to go. I've got the getting the portable scope charged up because I'll need to check the antenna voltages to make sure they're still in tune when I get those hooked up. Charging up the tablet computer here, which again we use to interface with the reader typically when I'm not using just my phone. Of course, in my pocket here I've got the Bluetooth adapter for the mobile reader. There's another Bluetooth adapter out at Oak Creek right now in the other reader. I did a little setup with the reader, gave it a name and a site code, for example. I had wired up the second battery with the extra cables, planning to take the first battery back home, charge it, leave the system off while I charged it, bring that battery back out here, and hook the two batteries up in parallel to be able to run for a while, because there's a storm coming, and I don't know, I'm not sure when the peak will be. It might be a few days. And I was thinking that these batteries, that one of these battery modules would only last for a few days. But it's been about a week. Well, it's been a week minus 3 hours. And when I got here, the first battery was still powering the system. So that's really good to know. One of these modules can power the system for about a week. I mean, again, almost exactly a week. So I'll go ahead and leave these cables attached. No particular reason to take them off in case I do want to parallel the system at some point later, parallel the batteries. But I will plan to simply replace the battery and turn the system on and leave it, because it should run for plenty of time for this storm system that's about to come through. I'm back home with the first battery, checking the voltage on it. So, as you can see, 21.17 volts. Well, I took the voltage, saw that it was up to